Alright guys, so I'm going to go through this fairly fast, but here are the advanced problems. What is the probability that a member of the audience will find a ping pong ball on their first attempt, given that there's 4 cups and there's a ping pong ball under 2 of the 4 cups, so there's 2 ping pong balls. And then what's the probability of drawing 1, and then without replacement, then finding a ping pong ball on your second attempt. So the problem looks like this. There's 2 ping pong balls under 2 random. We don't know which one. We want to know what the probability of drawing 1 is. So there's 2 out of 4. Now, here's the tricky part. Assuming that we solved it, or we found it, what's the probability of not finding a ping pong ball on our second attempt? So if we found one of them and we take the cup out and the ball out, and notice here, and where is it? Placing will not find, and then without replacing. So there's going to be now sample space of 3, and there's 2 remaining that are not. So when we multiply these, it's going to be 4/12, which reduces to 1/3. Now this problem here is very similar. The only thing is, what's the probability that an audience member will find both ping pong balls on his first 2 attempts? So they're here somewhere, we don't know. But the probability of finding this one here, well, that's 2 out of 4. 4 and then 2 ping pong balls, and then once we find that, now what's the probability of finding the third, or the second? Well, there's 3 options and it's under 1. So now we multiply these, which reduces to 1/6. Okay, this is an interesting problem. Wow, I was writing with the eraser. That's why it was kind of confusing. Okay, this is an interesting problem. Jordan uses 2 6-sided number cubes. The sample space for the first number cube is following: 5, 10, 15, 20, 25, 30. The sample space for the second number cube is 2, 4, 6, 8, 10, 12. If Jordan rolls both cubes at the same time, what is the probability of landing on an even number? Okay, so what this means is when we add these together, oh, no, I misunderstood it. Now I understand it. Okay, if we roll both cubes at the same time, do they want us to add it? If Jordan rolls both cubes at the same time, what's the probability of landing on an even number? I'm going to come back to this one. I'm sorry. I don't know if they want us to add all of these together, or if we land on a 10 and 10, then that would work. Or what about this? If I landed on a 25 and a 6, I'm still landing on even number. Let me come back to this one. My apologies. Wow, okay. Okay, next one. In math class, Gracie uses the 2 spinners below. What is, if Gracie spins both spinners, what is the probability of having an outcome of A, B? So we need A and B. So here, the probability is 1/3. And over here, it's 2/5. So we need A here and we need B here. So now, multiplying these together, we get 2/15. If it was AB or BA, that's something different. But I think that this spinner, they want A, and then this spinner, they want B. Okay, problem 2. A spinner is divided into 8 equal sections like the one below. If the probability of spinning a 6 first and an 8 second is 1/8, how many sections of the spinner should be labeled with an 8? One of the more difficult problems. So probability of spinning a 6 first, this is what I need to do. The probability of a 6 times the probability of an 8 is going to be 1/8. They give me the n probability of both of these things. This here is almost like my x. I don't know what this is. Once I figure out what this probability is, then I can turn it into a fraction. The probability of 6, well, that's 1/2. Now 1/2 times x is equal to 1/8. So now all I need to do is 1/2 times what is going to be 1/8. Well, I can actually divide 1/2 into 1/4 or 1/8, but 1/2, or I can also multiply by the reciprocal, which will give me x is equal to 2/8, which reduces to x is equal to 1/4. 1/2 times 1/4 will be 1/8. So, if the probability of drawing an 8 is 1/4, I need to make sure that 1/4 of this is an 8. 1/4 of it is going to be an 8. So I know how many sections? Well, 2 sections makes 1/4, and these are something else. So how many sections? There's going to be 2. Okay, Loretta wrote one letter of her name on each of the 7 note cards as shown below. Loretta shuffled the cards and turned them upside down so she could not see the letters. She chose 2 cards, one at a time. What is the probability that Loretta chose an O first and then a T second? So, of 7 cards, the O first, that's going to be 1 out of 7, and then a T second. She did not shuffle the cards and turn them upside down so she cannot see the letters. She chose 2 cards. What is the probability that she chose an O first and then a T second? Let's see. Okay, now this problem is, the difficult part of this problem is there is implicit, means kind of hidden, implicit non-replacement. We are not replacing the card, because once you pick a card, let's say you pick just random, okay, no, it's assuming this. Assuming that we find the O, which is 1/7, we've already uncovered that card. So now we have an option of 6 cards. And what is the probability? Well, there's 2. So it's going to be 2/6. Multiplying straight across, and then simplifying. C1/21. All right. Next one. Several people took part in a fishing competition. The table below showed the lengths of fish caught by each person. Joni was the first person to catch a fish in the competition. Based on the results shown in the table above, what is the probability that Joni's first fish was shorter than 17 centimeters? 13 centimeters. Okay. Well, there's 17, 28, 50, 40 fish total. So there's 40 fish total. And how many are shorter than 13 centimeters? 12. So we can reduce this, 6/20, and finally 3/10. So the answer is C. There's a total of 40 fish here, and 12 fish was our desired outcome. 12 or less than 13 centimeters. Next problem. Students in Miss Baldwin's class listed the number of people in their immediate families. The data appears in the box below. A new student joins Mrs. Baldwin's class in November. Based on the results shown in the box above, what is the probability that a new student will have 3 people in her immediate family? So, what's the total? So the total is 4 by 5. So there's a total of 20. And then how many have 3? Well, 1, 2, 3, 4, 5, 6, 7. Is that all? 1, 2, yes, 7. 7/20ths. What is the probability that a student will have 3 people in her immediate family? 7/20ths. Oh, I just counted wrong. 1, 2, 3, 4, 5, 6. Okay, sorry. Just testing you. 6/20ths, which reduces to 3/10. The answer is D. Oh, I gotta finish this in 28 seconds. Tony has a deck of 10 cards numbered from 1 to 10. 5, 6, 7, 8, 9, 10, and did not return the deck. She drew 3 cards. She drew a 5, so this one is done. She then drew a 2, so this one's done. Now, what's the probability of all the rest that she selects an odd number? So 1, 2, 3, or 4. So it's 4 out of 1, 2, 3, 4, 5, 6, 7, 8. 4 out of 8. 1/2.